Hello, everybody. How's your Saturday going so far? I just woke up. Hello to Aid3NXR, Peter, Josh, Editing Q Alex, Liam. Hello and goodbye to Big O. Hey Pasquale, J40, Meadow, Karma. Hey Philip, welcome. Hey Jay and more crabs and Liv. Hey the Asylum. Hey Philip again. Sorry. Hey Florian. Hey Andrew. How are all of you? No gift membership yet? Yeah, I don't have the option to enable it, so I'll look out for that. Hey Ictus. I'm just drinking my Soylent here. Hey Machiro, yeah, you were. I noticed that. Suggestions seem to help. Hey Martin, yeah, this Saturday morning stream was designed for Europeans to be able to watch it. At least I hope that's how it worked out. We don't do word games, but we do a lot of good Sudoku. Give me 1 second. Erica, don't keep them again. All right, sorry about that. I'm hoping to, between this stream and next stream, or between this morning stream and this evening stream, I'm hoping to see Doctor Strange. So we'll see. Hopefully that'll work out. My wife and I will go out to eat something and see Doctor Strange. So that should be fun. Yeah, where are my mods? Well, I know where Derek is. Derek's still in Italy. David's here. Hey, David. Hey, Blobz. Welcome. Luckily, I think the moderation duties during the Sudoku streams aren't as difficult. More crabs already solving the puzzle? I haven't even introduced it yet. Alrighty, well, speaking of introducing, this is High Voltage by Florian Wortmann. Florian's a avid watcher of my streams. I think he's in every one of them that I can remember. Alright, and he's here today. So, we have normal Sudoku rules. That's good. Standard, looks like we have standard constraints here, except some ambiguity. So these thermos are thermos. What that means is they're thermometers. It means that there's a bulb end, that's the circle, and then there's the line of the thermometer. So from the bulb end, digits have to strictly increase. So if I put, say, a 4 here, I have to be larger than 4 here. It doesn't have to be 5, but it could be like 6. Then I could do, say, 7, and then I could skip to 9, and that would be a valid fill for this thermometer. What you can't do is say, after the 7, go back down to 5, because 5 is not bigger than 7. We have to increase. Renbans are lines where digits have to be consecutive, but in any order. So, for example, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6 are consecutive numbers. And so we could do, say, 2, 3, 4, 5, 6. And even though these aren't in order, there is the consecutive numbers 2, 3, 4, 5, 6 on the Renban, so that's valid. And what I can't do, though, is 2, 3, 4, like I do put a 7 here, because now 7 has nothing consecutive with it on the line anywhere. So that's not valid. And then German whisper lines. And again, there's some ambiguity, so that's why I'm using the same line here. That just means that there's a difference of at least 5 as you move along the line. So if I put a 4 here, the only number I can put here is 9, because it's the only number that's at least 5 different from 4. But then from the 9, I can do, say, a 1 or a 2, because you just have to be at least 5 different. And, this is 7 different, so that matches. What I can't do is put, say, a 5 here, because that's only 4 different from 9. All right, and so the orange lines are either Renban or Whisper, and it's up to us to determine which is which. So every individual orange line, we have to determine whether it's going to be a Renban or a Whisper line. So it's an ambiguity puzzle. And then where it is clarifying in this cell here, these lines cross each other, they don't form these. So this is not the continuation of the line. It goes like this. Ooh, like that. And then this one goes like this. All right, so those are the rules. So let's see how we want to get started. Well, the first thing we want to notice about a 5-cell Renban is it must contain a 5. So that's something we want to keep in mind, because I can do 1, 2, 3, 4, 5, or I can do 5, 6, 7, 8, 9, but either or anywhere in between, but all of them are going to contain a 5. For whisper lines, they cannot contain 5s. So if a whisper line is, if I try to put a 5 on a whisper line, what do I put after it? Right? I have to be at least 5 different. Well, I can't do 0 or 10, so that's not going to work. Also, 4 and 6 are heavily restricted on whisper lines, because if I try to put a 4 here, well, 9 can go next to 4, but it would have to go next to 4 on both sides, and then you'd have 2 9s in the row. Same with 6, you'd have to have double 1. The other thing about whisper lines is they change what we call either parity or high-lowity, where you're going to get a digit between 1 to 4, and then you're going to get a digit between 6 to 9, and then you're going to get a digit between 1 to 4, and it flips back and forth because you're adding and subtracting at least 5 every time. So those are the big tips I have for those two kinds of lines. So let's think about this a little bit more. Thermos, one thing to know about, which is what more Krabs is getting at, is where do 1s and 9s go on thermos? Well, a 1 can only go in the bulb of a thermo. If it's on a thermo at all, it's going to go in the bulb, and a 9, if it's on a thermo at all, it's going to go in the tip. Because otherwise you can't, if I put a 9 here, how am I going to get bigger than 9 for the next cell? Hopefully that's clear. So the question is, where do 1s and 9s go in these two columns? Well, 1s have to be in the bulbs, can only be in the bulb of a thermo, so they're restricted to these cells, and 9s are restricted to these cells. And those form, I guess I don't know if I want to color them, but I'm going to corner mark them and see if I can remember that that's what that means. But that forms an X-wing, which means that basically for this row and this row, the 1s are accounted for. We need 2 1s in those rows, and they're used up by the ones that happen in these columns, specifically these ones here. If I try to put another 1 somewhere in these rows, then now there's nowhere to put a 1. I can put a 1 here, but now there's nowhere to put a 1 in column 7. Or I can put a 1 here, but now there's nowhere to put a 1 in column 3. So that's called an X-wing, because it kind of forms an X pattern. If you kind of draw a line, we're either going to have a 1 here and here, or we're going to have a 1 here and here, and those are the only 2 states of the world. So we can't put a 1 anywhere else in these rows, and then the same exact thing happens with these 9s. Oh, bet cell. Yes, the bet cell is row. Where's my... Did I lose my setting? Oh, I know what happened. let me turn on the pen tool. Okay. The bet cell is row 2, column 1. All right. Let me adjust something here. There we go. Hey, Listesh, welcome. This line here seems difficult to be either Renban or Whisper. I wonder which one's more difficult. I'm gonna pencil mark these thermos so I can get an idea of what we're dealing with here. I mean, okay, so these go 1 to 6, so that's a lot. But let me point out what I want to point out here. So I'm going to color these and show that if this were a German Whisper line, these two would have the same parity as each other. They'd have the same high-lowity. So the only way that would work, let's see, is that this could be a 4, and then we'd have a 9, and then we'd have a 1, 2, or 3. That works. Or this would be a 6, this would be a 1, and then this would be a 7, 8, 9. That works pretty well. Oh, I see. Yeah, so if this was a 4, let's do the rest of the thermo. This would be 3, 2, 1. And then this would have to be also low, but it can't be 1, 2, 3, or 4. That's all the lows for the row. So actually, maybe good lifting this wasn't as helpful as I thought. But basically, if this is low, let's actually look at both cases. If this was low, then obviously the rest of the thermo is low because they're lower than this cell. You only get 4 lows in a row, which would mean both of these would have to be high, and then that breaks the high-lowity rule for whispers. The other option is both of these are high, but then we get 3 more highs above here, and we now have 5 highs in the row. So it's actually not possible for this to be a whispers line. This is a Renban. So that does put some restriction on the Renban, because this is minimum 4, and this is maximum 6, right? So don't they have to be the min and max? And then it's... Ah, yes, the links. My mods are not reminding me of stuff. Here's the links for you guys. So I think that this has to be 4, 5, 6. Do you guys agree? Yeah, that's what Peter said. Well, no, this could be higher though, couldn't it? Couldn't this be like even 9, 8, or not 9, but this could be like 8, 7, 6, couldn't it? No, I don't think it has to be 4, 5, 6. Well, if this is 6, then this is 7, 8, 9. That's forced. And then that's going to force this to just be completely consecutive. 5, 4, 3, 2, 1. So this being 6 does force that. So either we're this just 1 through 9 straight across, or the 6 is lower, say a 5. we could do 5. This couldn't be a 4 anymore, right? Well, hold on. I think what... or this could be a 4. Wait, if this is a 4, 3, 2, 1, then basically there's a 5, 6 pair here in order for this to be 7, 8, 9. Okay, can we do anything other than 4, 5, 6 on here, I guess is the question. Like, can I put a 3 here? Yeah, this could be 5, 4, 2, 1. No, but we need the 4 in between. Hey, Pause, welcome. If this was a 3, I obviously have to get bigger, right? I need bigger numbers here. I can't do 2, 4, because 4 is... there's just too many lows here. So I'd have to do 4, 5 in some way here. Hey, 3 months from Pause. Thanks so much. Pause has been a super supporter from the very start. Thank you so much, Pause. She says, yay. All right. I know it can be 4, 5, 6 in any order, but I don't think I can do a 3 anywhere. Like, even a 3 here. If this was 3, 4, 5... how do I get 3 digits less than 3, 4, 5 here? It just doesn't work. And if I try to put a 7 anywhere, just try to put a 7 anywhere here, would have to be in one of these two. Then I need to have, the best I can do is 7, 6, 5 here, and then I need 3 more digits bigger than 5 that aren't 7. Wait, 6, 8, 9? But then the 6 can't go on here. So it just doesn't work. This has to be 4, 5, 6. And then these are the 3 digits less than 4, 5, 6. So those are filled. Oops. And these are the 3 digits bigger than 4, 5, 6, so they're filled. And that completes the X-Wings. Did I do that right? Yeah, I think I did. Wait. Yeah. All right. Too bad to anyone who bet 9 already, right? This seems hard to be a whisper. So this would be high, these ones would be high, and these would be low, which makes these high, like this, Oh, maybe not that hard to be a whisper. So this would just be 6, 7, 8. This would be 1. This sees 6, 7, and 9. This would have to be 8. And then that breaks. Yeah, okay. So there's no way for this to be a whisper line. I guess they wouldn't both have to be whispers, though. So all that proves is they're not both whisper lines. Philipp says neither row 4 or row 6 can be Renban. Okay, so if this line were a Renban, then it would be 1, 2, 3, 4, 5. And that's just way too many 2, 3, 4, 5, 6s in this box. Where do first of all, where does 9 go? That's the easiest thing to see. The easiest thing to see is that there's a 9 here. And if there's a 9 here, it's not a Renban. And then there's a 1 up here. And if there's a 1 here, it's not a Renban. Or sorry, yeah, not a Renban, yeah. So they're both whispers, so we should actually be coloring these anyway. Let's color all these, and then we can color this line here. Oops, that means the 9's not there. And then we can color these large. That means the 1's not there. All right. So this is from 2 or 3. These are from 1, 2, 3. And this one is a 4. This is blue. And so now in this column, where does the 2 go? It can't go, it's not bigger than 4, and it can't be this high in the Thermo. So the 2 goes exactly here. This can't end in 9, so this could be 8, 7, 6. So this is 5 or 6, 6 or 7, 7, 8. And this is whatever's left over. Oh, the 4 has to be next to the 9, so that gives the 9. Column 3. What are we saying about column 3? Well, this is a 6. It's the high, so that's the 1. And then where does 8 go? Can't be less than 6. So 8 goes here. And so this is 1, 2, 2, 3, 3, 4. No, wait, hold on. This can't be 1. So this is 2, 3, 3, 4, 4, 5. Wait. I think there's one more degree of freedom. 2, 3, 4, 3, 4, 5. No, this can't be 6. What am I talking about? Okay. That's it. I was correct the first time. So this could be a whisper at first glance, because these are both low. Could this be a whisper? This can't be a whisper because we're out of lows. This is either 5 or it's a high. So this is a Renban. I should probably mark the Renbans in some way. This is a Renban. So if this was a whisper, this would be high. Okay, we know that these two are high, right? This would be high, high, high. This one can't be high. It's either 5 or low. So this is also a Renban. So at lowest, this could be 7, 6, 5, 4, 3. At lowest, this could be a 3. So this cannot be a 2. Because if it were 2, we'd max out at 6, and this is a 7 or an 8. So the 2 in the column goes here. Sorry, we know that this is low also. How high can this one be? We might be able to get the 8 out of here. No, we could do 8 through 4, it looks like. It's not the same. So this is from 3, 4, 5. Okay, so the question is, can all of these be Renban cells? We could make this extreme, 1, 2, 3, 4, 5. Well, we'd have to hide a 5 here or here, for sure. This would get the 5. It would be like 1, 2, 3, 4, 5. And then this would have to be 5, and then or 5 on one, probably 5 on this end, maybe 4. But we could do 5, 6, 7, 8, 9, right? Seems possible. Two in box 3 does go here. Oh. So then this can't be a high Renban at all. So if this has a 2 on it, we know it's a Renban. So we're from 1 through 6. And we definitely have 2, 3, 4, 5. It's just the 1 or the 6 that's free here. This can't be 1, 2, 3, or 4. That's a 5, 6 pair. That can't be 1. 5, 6 pair means this is 7 and 8. 8 means this can't be a 3 anymore. This can't be 6 or 2. Or 3. Oh, this is a Thermo, so it can't be 3. That's a 4 or 5 pair, so that's a 3. Ram, I for a year and a half, or a year now, I've been doing a stream on Saturday mornings. It's a Sudoku stream. That's fine. I don't expect people to have my schedule memorized, just answering your question. Row 2 is a whisper. So yeah, so how can we make this... Right, so that forces a 3 here. Well, does that help? So if this was a Renban, we would be either 1, 2, 3, 4, 5, or 2, 3, 4, 5, 6. Why would that be broken, though? Because that's 6 digits for 6 cells. We'd have 7, 8, 9 up here. I actually think that works. Unless someone can convince me otherwise. These are 7, 8. Hey Tom, welcome. Wait, Derek's here? Hey Derek. I'm just going to fill these quads because I see it. Relaxing at the hotel? That's awesome. How was Tuscany? Philip, if you ever stream, you're going to pick a random hour to start once a week. Just keep people on their toes. Sounds like a good way to keep your viewer count low. Oh, yeah, no 4 here. So if this was also a Renban, is that a problem? Because it would definitely be 9, 8, 7, 6, 5. This couldn't be 7 or 8. This couldn't be 8. So we'd be forced to put the 8 here, actually. And then this would be a 5, 6 pair on the line, so this would be a 7. And then that feels like a problem for this line, because this is a Renban line, and now there's nowhere but 7 on it. And there's an 8, so we need a 7. So that's broken. So it has to be a German Whisper line. So we can mark these as low, and this one's definitely high. So if this one's high, it's not an 8 or a 9 or a 7. So it actually has to be a 6. No, that doesn't work. It sees 7, 8, and 9. No, it doesn't see the 9. Okay, so it is 9. Never mind. I was thinking it saw it through the German Whisper, but that's just not how German Whispers work. I'm getting confused. So that does not restrict these at all. But it does mean that these need 6 and 7, and this has to be a 5. So that resolves this. This is 6, this is 5. 6 is high. Let's make our 5s gray. This 6 sees over, so that's 7 and 6. 7 sees up, that's 8 and 7. This resolved quite a bit. This is not a 6 anymore. Neither is that. So this is definitely low, so is this one. The 7 can't be next to a 3, so that's 2 and that's 3. This can't be 2 anymore. Six must be next to 1. It's not a 1. These 9s don't restrict the cell. if this was Whisper, we'd only have one high left. So the high would be here, it would be a 9. Oh, this 2C's up really, really far to make that a 3. Did I get all the cleanup? Probably not. Right. Oh, no. Hold on. If this was a Whisper, this would be high, low, high. And then this would see 6, 7, 8, and 9. So that doesn't work. So this is a Renban for sure. These can't be 6, 7, or 8. So we got to go down. So this can't be 8, right? Because we need, 7, 6. If this was an 8, we need a 7 on the Renban, and we can't. So it's not an 8. If this was a 7, we'd either need an 8 or a 6 on the Renban, and we can't. So it's not a 7. If this was a 6, we could go 5, 4. We can't go up to 7. If this was a 5, we can't go up to 6, so this would be 4, 3. So it always has a 4 on it. This can't be 5. These can't be a 3. Right, I should clean this up. So this is a 2, 5 pair, so this is a 6. So this should be one of these numbers. It's not 6. It's not 5, 6, or 8. So it's a 7. Okay. So if this is a 6, I need a 5, and then I need a 4. That's 8 and 5. Okay. I think for the Renbans that are finished, I don't need to mark them Renban anymore, so we can kind of reduce the amount of coloring we have going on. Right, 5 is placed in box 8. That looks up. Obviously, if this is a 5, this would be a Renban. This couldn't be 6 or 7, so we'd have to go 5 and then... Well, it couldn't be 4 either. So if this was a Renban and a 5... So if this is a 5, this is a Renban. This can't be 4, 6, or 7. So it would have to be 3, and this would have to be 4, and that works. So this would be 3, this would be 4. If this was a Whisper line, this would be low, this would be high. It sees 6, 7, and 9, and 8, so that doesn't work. Now, if it's a 2 and a Renban, then this can't be 1, so we'd need to be from... We'd have to be 2... Wait, this could be 1, though. So if this was a 2, this could be 1, and this would be 3. If this was... or we could go up to do 3, 4. This couldn't be the 4. So I think no matter what, this is a 3. This is a 2 or 4. Not 2 or 4. 1 or 4. And it's not a Whisper. Because this cell can't be high. That's crazy how that turned out. I'm being told to put candidates in for the box 8. So let's do that. We need 2, 3, 4, and 8. Yes, that places the 8. These are low. This can't be 2 or 3, so that's a 4. And I think we're left with a 2, 3 pair. Oh, that 4 C's over, so that's a 1, that's a 2. And this is a 5. There's a 5 up here somewhere. That cell has a 50% chance to be a 5. This 4 C's up. Put a 5 on here. Finally disambiguating this. So this is gray. This is a pair left. We have 1, 2, 3, 4. We need 7 and 8 only. So this is high. I think that makes this not a Renban. 7, 6, 5. Yeah, it just doesn't work. So these go every other. This is 1. It can't be a 4 because of the 7, 8, and it can't be a 2 or a 3, so it's a 1. That makes this a 2, 6 pair. And then this is not 7 or 8, and it's not a 6, so it has to be the 9. And then this 2, 3 pair looks up, making this 6 and 2, 4 and 6. And I'm going to remove the purples because these Renbans are done. What's this pair? It should be resolved. We have 1, 2, 3. I need a 4. So the 4 goes here, and I need a 5, which goes here. That places 5 in the bet cell. Congrats anyone who bet 5. What do I need here? I have 1. I need a 2. 2 and a 9. Okay. Here I need 2, 3, and 6. It's not a 2. Or a 6, so that's a 3. This is a 6. This is 2 and 3. Looks like all our lines are done, so it should just be Sudoku. What do I need in this box? Oh, there's a 9 in this box, so that's 2 and 9. We need a 4 in the box. And then here we need both lows, 1 and 2. You know the order. Let's see, I need a 3 in this box. That goes here. I need a 4 in the box. That goes here. I have 5. I need a 6. 6 goes up here somewhere. In fact, all these are high. I need a 7. That goes here. I need an 8. Looks like 8 can go anywhere. And I need a 9. That goes here or here. Okay. I need a 1 in this box. That goes here. The rest of this is high, so we're done coloring. This is an 8, and then this would be 6, 7, 9. It's not a 6 or a 7, so we have the 9. That comes over, gives us 8, 6, and 9. The 6 looks over, giving 7 and 6, 8 and 7, and we're done. Thanks, Florian. Yeah, neat puzzle. I enjoyed it. Alright, give me one moment while I prep the next puzzle. All right. This is Incendiary Arrows by Miky. I've been told this is a harder one. My testers had trouble with this one, so this is going to be our hard one for the stream. Means we finally got through all the pile of hard ones that we were doing one at a time. So that's good. We got through them. So we have just standard rules, though. We have normal Sudoku rules, standard arrows, and standard even odd. So what are arrows? Well, digits along an arrow sum to the value in the circle. So if I were to put 1, 2, 4 here, then that would add to 7. 1 plus 1 plus 2 plus 4 is 7. So we'd fill a 7 in the circle. That's how the arrows work. And if we have 2 arrows coming out like this, that means that they all sum to the same thing. So if I put a 5 here, well, this sums to 5. And then this could be, say, 1 and 4. So it's not that you add all 3 of them to make this. It's 2 separate arrows that happen to overlap, basically. So that's how those work. And even odd. So squares are even cells. They have to be 2, 4, 6, or 8. And circles are odd cells. 1, 3, 5, 7, 9. And the way to remember that is a circle kind of looks like an O. And a square has an even number of sides. That's how I remember that. And our bet cell is here. This doesn't do anything. It's just you bet on what you think this cell is going to be at the end of the puzzle. All right. Lista says Miky doesn't usually take prisoners. Yeah. So the first thing about arrows that's a little bit interesting is a 3-cell arrow, when you can't repeat on them, must be at least 6, because 1 plus 2 plus 3 equals 6, and that's the lowest you can put. So these 2 are at least 6. I'm wondering if we should do even odd coloring. So let's just color all of our known evens and odds with our standard parity coloring here, where blue is even and orange is odd. O for odd again. You win bragging rights. Let's see. So let's okay, so yeah, one thing that I learned a long time ago that's easy to forget is a 2-cell arrow. So an arrow that sums 2 values to a circle. So I would call this a 2-cell arrow, even though it occupies 3 cells. But a 2-cell arrow always has an even digit on it. Because imagine I tried to make all 3 of these odd. Well, that would mean that 2 odds equal an odd, and that's not true. 2 odds equal an even. So there's always at least one even number on these. But because they have an odd on them already, it means that you can't have, you can never have 2 evens and an odd. Oh no, you can't. You can't have 2 evens and an odd. If you have 2 evens and an odd, it goes this way. So maybe this wasn't the point I'm just going for. But anyway, it's still nice to know. Or you'd have the even here, in which case this would be odd. So we're always going to have an even and an odd on these. Ah, yes. And so, right, we can't have 2 evens. That's the point. We can't put 2 more evens on here because an odd plus an even is an odd, so that doesn't work. So where do our 4 evens go in the row? We can only put 1 here, exactly 1 here, exactly 1 here, and then these 2 are even. So that's the point there. Hey, Nolan. So if this cell were odd, then this would be even. And if this cell were even, then this cell would be odd, just by adding up our parities here. So our evens are done, making these 2 odd. Because we get the 4 evens in our... These 5 cells have all 4 evens. And so how do we fit 4 evens? Because the 2-cell arrows are either going to have 1 even on them or 3 evens on them. Exactly. You can't have two evens on an arrow. Because I can't put them both here, because that would make this even as well. And I can't make both of these even and then this one odd, because that makes this even. So if you put two evens, there's three evens. If you put one even, you can't put no evens because three odds doesn't work. So we're going to have either exactly one or exactly three evens here, exactly one or exactly three evens here. If I just did one even here and one even here, then I wouldn't have enough evens for the row. So one of these is one even, and one of these is three evens, leaving only odd for this one. So that can actually be filled, making it a 7 or a 9. I was getting there, guys. I like to explain it for people. So you can't exceed 6 on a 3-cell arrow. So the 8 is down here. We can't put both 4 and 6 on here, so there's definitely a 2. And now we should look at these because I think it's the same deal. So yeah, it's exactly the same. We have exactly one even on both of these. These two are even. That means that this has, of these 5 cells, we have all 4 of our evens. So these two are odd. And that means now we have 3 evens and 1 even. All 4 evens are taken, making this one also odd, making it I make the same exact mistake also, making it a 7 or 9. And then that makes this even. This has the 2, this has the 8. Now column 5 has all the evens, so these 3 are odd. Our bet cell is odd. This is 1, 3, or 5, just to mark that. Oh, true. It can't be a 5 because this has a 2 on it. So if this was a 5, we'd have 5 plus 2 is 7. We'd have to add to 9, which means we need another 2. So it's 1 or 3. If this is a 7, then that forces it to be 1. So if this is 7, then we have 1 here with a 2, 4 here. If this is 9, then we could have a 1 here with a 2, 6, or we could have a 3 here with a 2, 4. So that doesn't really help, does it? But I may as well mark that. Let's see. These 2 cells have to go in this box somewhere. This one can't go here. It doesn't seem all that useful. Never mind. Okay, so Garyon is talking about we know there's an all blue arrow in this row and this row. 2 of these arrows are all blue. We don't know which ones, but Garyon's saying the 2 options are either 2 plus 4 is 6, or 2 plus 6 is 8. That's it. You're always going to have a 2 on it. What's the issue here? I don't see the issue at 246. I just don't see it. Just one example. There'd be an 8 somewhere here. Sorry, I don't see it. Carry on. So you're saying, okay, so you're saying if this is 246, this arrow also needs an even. And the only even left is 8. But it now sees 246 and 8. Okay, so one way to put that is there's an even on this arrow, and it's not an 8. So if this were a 3 even arrow, it would have to have the 8 on it. So it would have to sum to 8. So it can't be 246. All right, I get that. I don't know what to do with it, but I get it. Is there a conclusion from that? It's just there's pointing 8s, so. Okay, so it means that, well, okay, so it means that and the same thing happens down here. So it means that we can't do this. We can't have the evens like this, because then both of these are 8. So it means there's an X-wing on 8s here. Which means there's an X-wing on 8s here. Ah, okay, I get it now. So we've just proved that we can't do anything like this, because that would double up 8 in the column. And now we can't do this and this, because that would double up 8 here. So we actually found that the evens have to be here. These are all even. And these are 8s. Sector. Yes, and you make 8 with 2, 6. Oh, we get more digits. So that places 8 in this box. Whoops. And it should do the same up here. Places 8 here. So now this has a 4 on it. And so does this. And so does this. And this. So these 4s point into this box, making this a 2, 4. And this a 2, 4. Making this, both of these 6, 8s. So there's a 2 on here, and there's a 2 on here. Can't add to 2, so the 2 gets placed. Making these odd. That makes, yeah, that makes sense. That looks up, making this 6 and 2. 6 and 2. Sixes go here and here. Ah, this 6 is placed. So is this one. So now these are odd. These are all odd. This 1, 3 goes down here somewhere. And it doesn't go here. So this is a 1 or a 3. I guess this could be a 1 or a 3. Oh, okay, okay. So this 1, 3 cell goes somewhere on this arrow, because it can't go up here. So it can't go in the bulb, because we can't do 1, 2, 3. There's a 4 on. If this were a 1 or a 3, this would be a 4. That doesn't make sense. So it's either here or here. If it were here, then this is a 1, 3. If it's here, this is a 1 or a 3. That forces a 4 here, making this also a 1 or a 3. So no matter what, this cell's a 1 or a 3, but we don't know if it's the same or different from this 1, 3. So that's interesting. Can we do the same thing here? Yeah, we can do the same thing here. So we either have 1, 3 plus 1, 3 equals 4, or we have 1, 3, 1 plus 4 equals 5, or 3 plus 4 equals 7. So, that's how that works out. This is 6 or, wait, this is 4 or 6. Where does this cell go in this box? This cell we know goes down here, so it goes up here. And it can't be in the bulb because of many, many reasons. But let's just say because it sees this. So this 1, 3 goes down here somewhere. But I don't know. I don't know exactly what to do with that yet. I could give it a color. It's not the same, is it? Okay, so let's fill this then. So this could be 1. Okay, so this can't be 1 plus 2 equals 3, because then that breaks this cell. So this would have to be 3 plus 2 equals 5, or 5 plus 2 is 7, or 7 plus 2 is 9. Any of that restricted. Now, if this were 3, 4, 7, then this, oh, okay. So if this were 3, 4, 7, this would have to be 5, and this would have to be this would have to be 9, and that just doesn't work. Because 5 plus 2 is not 9. So this cannot be 3, 4, 7. So this can't be a 7. So we're either 1, 4, 5, or 1, 3, 4, or 3, 1, 4. So this is never 3. Oh no, this could be 3. Yeah, okay. This could be a 1, 3 pair with a 4, or this could be 1, 4, 5, but it can't be 3, 4, 7. Okay. I think it's the same up here. So this is 3, 5, 7, and this is 5, 7, 9. Feels like that ought to have been useful, but... this can't be 3 plus 2 equals 5. If this was 3, 5, then this would have to be 1, 4, 5. That doesn't work. So this is not 3 and that's not 5. Same thing here. So this always has a 7 on it. So this 7, 9 cell goes here, because it can't go on this arrow, which means it goes down here. So this is matching one of these, but that's not as helpful as I was hoping. What's wrong with 1, 4, 5? What we can't say is there's both a 7 and a 9 here, so this is from 1, 3, or 5. Perfectly symmetrical so far, other than this. So this always has a 1 in it, right? Because either 1, 3, 4 or 1, 4, 5. So this is not a 1 or a 7, so it's 3, 5, or 9. That's true. These are asymmetrical, so... What does it break? I'm being told this can't be a 9. If this was a 9, this would be 4, 5. Ah, I think that's true. That's a good spot. So if this were a 9, then this would be 4, 5. And then this would be, what, 7, 7? doesn't work. So this is not 9, which means there's no 9 in the box other than here. So this is 9 and this is 7. I think we can do the same thing here. Yeah, 9, 4, 5 would break. So this is 9 and this is 7. So the least surprising result, though. So this, if this is even, it's a 4. Otherwise, it's odd, in which case it's higher than 4, so it would have to be a 5, right? Yeah, 6, 7, 8, 9 are just used in the box. So this maxes out at 5, but it can't be lower than 4. If it's lower than 4, then 4 is on the arrow, and that doesn't make sense. So that's a 4 or a 5. So this makes a 4-5 pair between these two. So this is either 1, 4 adding to 5, or 1, 3 adding to 4. So there's a 1 in here. So now 1's point over, making a 1 here or here, but we know this one's not 1 because these ones point. So the 1 goes here and the 1 goes here, making these 7s. These are not 1s. Hey Donald, welcome. So these are from 3, 5, 9. Seven goes here somewhere. 1 goes here. Three, 5, 9 triple here, true. 3, 5, 9 triple here makes this a 4. And finally we've broken the symmetry. These are 5s. So these are evens and these are odds. These 5s look over, making this a 5, making this 4 with a 1, 3. And then this 5 looks down, making that a 3 and that a 1. This doesn't get resolved? No, the 3 also. So that's 4, that's 5. So this is, oops, 3, 7, 9. That's not 7, that's not 9. This is where the 5 goes. 1 and 3 are both odd. So this is not 1, 3, 5, so it's 7 or 9. In fact, where does 3 go in this row? It only goes here. And this is a triple 5, 7, 9. It's not 7, that's not 9. This 4 looks down, Listash says. I still need a 4. I need a 4 in the column. That goes here. Makes this one the last odd. It's not 1 or 3 or 5, so it's 7 or 9 also. I need a 4 in this column. That goes here. Two goes in one of these. So this is 2, 3, or 9, it looks like. Am I done with 4s? Not quite. Oh, this 4 does look up though, so that's 2 and 4. That's 2 and 4. Now am I done with 4s? And once I do this, I think. 1, 2, 3, 4, 5, 6, 7. Okay, I'm done with 4s. Not done with 1s. What about 8s? That's not 5, so that's the 5. That's a 9, that's 3 and 9. This is 1, 3, 9. 3 goes in one of these two. I need a 6 in this column, it goes here. So this one's the odd. These two are from 1, 3, 7. Looks like one of them is definitely a 1. Wrong pencil mark. Where? Right, so 2 in this box has to go here with the 3. That's a 2-3 pair. How is this? Wait. Not a oh, the 3s were wrong. This is 2, 6, or 8. These are all even. I have 1, 3, 5, 7, 9 already taken. So these are 2, 6, or 8. That's not an 8, that's not a 6. So I need a 7 and then the last even here, which isn't a 2 or a 4. So 7, 6, or 8. But this can't be 6 or 8, so that's a 7. This can't be 6, so that's 8, 2, and 6. That's 8 and 6, 8 and 6. That's the 2. These are odd. Can't be 1 or 3, so they're from 5, 7, 9, but that can't be 5 or 7, so that's the 9, that's 3, that's 1, that's 7, that's 5. This sees 1 and 9, so that's the 3. That's a 9, a 1, and a 9. Betzel was a 9. Congrats to anyone who bet 9. This is the last even, it's a 2. It makes all these odds. We're done with coloring. So this is 1, 7. I can do it this way. 3 and 1. 3 and 1. 5 and 3. 9, 7, 5. 9, 3 and 7. Wow. Hey, that didn't take long at all. We will not consider that the hard one for the stream because we did it in 30 minutes. That was a great puzzle. I loved it. I feel like early on in my streams, Listesh taught me a whole lot about two-cell arrows, and that really helped in this one. You remember that, Listesh? When I mean early on the stream, I mean my early streams. Yes, so don't forget to like the stream. Also, make sure you're on live chat. So if you don't know what that means, if you look at the top left of your chat window, it says top chat with an arrow. You click on it, you switch to live chat. It lets you see everyone's chat. I'm going to prep the next puzzle. Give me one moment. All right. Give you guys the links. Actually, there's just one link for this one. Okay. So this is called Xclusive Nights. It's by Blobz. We have normal Sudoku rules. All right, each n-sized cage contains the digits 1 to n exclusively. So I'm guessing this is a 1. You can just fill that now. This contains 1 and 2, etc. So this is a 5-cell cage, so it contains the digits 1 through 5, etc. Cells separated by a chess knight's move cannot contain the same digit. So let's use this as an example. So this this 1 here, if you think about how a knight moves in chess, sometimes called the horse, where can it move? It could move here, because it can go down 2 and right 1. It can move here, here. It can move here, 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 and here. So there's 8 cells that a chess knight can move to, up to 8. So let's just mark those in orange for a second. So what this is saying is that none of these orange cells can be a 1, because we filled a 1 here. And so none of these cells can be a 1. And that's in addition to normal Sudoku rules. So you can see here, we marked this one orange. So we can actually put a 2 and a 1 in that order because of that rule. Because a 1 and a 1 here would break the knight's rule constraint. Cells separate by an x sum to 10. Not all such x's are given. So that's just here twice. These 2 sum to 10 and these 2 sum to 10. So if I put, say, a 4 here, this would be a 6, making those add to 10. However, that does not prevent me from putting a 9 here, because even though these sum to 10 and these sum to 10, we're not required to have all of our x's. Not all of them are given. Okay. And this circle is just our bet cell, as usual, so you can bet on that if you'd like to, and win bragging rights if you get it right. All right, well, we already got started, so we'll keep those in there. We know there's a 1 somewhere here, and in general, this is 1, 2, 3, 4. I don't know how many of these I want to mark, but at least the small ones. These small ones are good to mark. That makes this a 7, 8, 9. By knight's move, this sees the 1, so that's not a 9. A tour of my house? What's this about? Right, so this is 1 through 8, so this is just going to be a 9. This is going to be an 8 and a 9, and this is going to be a 7, 8, and 9. This sees the 9, so that's 8, that's 9. That's not a 9. One of these is a 1. These are not 1s. So there's a 2 and a 1 in here. The 2 sees these 3 cells, so one of these 2 is a 2. The 1, unfortunately, just sees there, so there's no kind of... Oh, the knight's move hits here for the 1, so the 1's in here somewhere, but that's not that exciting. Right, these 1s point left, so that makes this a 1. The 2, 3 pair points right. Removing 2 and 3 from those. Removing 4 from here. I could put 6, 7, 8, 9 here. I think that's helpful. So the other 6, 7, 8, 9 is either a 6 in here, or a 6 here, or anything here. Two in box 4, you say? Yeah, so these 2s look left, and then this pattern is interesting. Let me explain this pattern. So if you have 2 is limited to the blue cells in either the row or the box, however you want to think about it. But if we have two orthogonally adjacent cells that have been, a certain value has been limited to them, then you can move in that same direction down to these two or up here. We can't highlight those because we can't get off the board. But think about these two cells. Can either of these be a 2? Well, if this was a 2, it would eliminate a 2 from this cell, but it would also eliminate a 2 from this cell, and then we'd have nowhere to put a 2 in these blue cells. So another way to put that is, the 2 is here or here. No matter what, that sees this cell and this cell. So neither of these can be a 2 or a 3. And we know that 2's look over, and so that leaves just here for a 2. We also know that the 3 is not here. So there's a 3 somewhere in here. We don't know where, but it's in here somewhere. And there's a 3 in this cage somewhere. So that uses up all, we get 2 3s in 2 rows. That uses up all the 3s for the rows, leaving a 3 in just one of these 2 cells for this box. And this 2 looks up here by Knight's Move, so that's cool. And that makes this an 8. I'm sure I'm going to be missing Knight's Moves left and right. So these 2s look down. There's a 2 somewhere here. So this can't be 1 9 or 2 8. So it's 3 7 or 4 6. So where does the 8 go? The 8 goes somewhere here. So those 8s look up, making an 8 here somewhere. If this were 4 6, that would put a 4 6 here. But 3 7 would just put a 7 in one of these 2. We're saying these ones look down. Okay, so where does 1 go in this box? This one looks down, and it's not in any of these cells, so 1 goes here also. I'm going to get back to this in a second, but that means these ones look up, and it joins the 8s, making a 1-8 pair. But also, this formation's interesting, because we can't not have a 1 in one of these 2. If we didn't have a 1 in one of these 2, then I could only put 1 1 in this group of 4 cells, because every cell sees every single other one. So I must have a 1 in one of these 2 cells, which I have no idea how to mark. So let's try to remember that. It points right. Basically, this cell can't be a 1. That's all it does. I'm being told to look at column 7. Right. So this 1, 2, 3, 4 quad leaves them out of here. So there's only 4 cells left that could have them. But this sees a 1. This sees a 2. Being told 3 in column 1 is interesting. Yes, it is. So this 1-8 pair eliminated possibility of 3 being there. So 3 is not in any of these cells because of this 3. So this has to be a 3 7. That puts a 7 in one of these 2. So now this is a triple. We have 1, 2, 3. We need 4, 5, and 6. It looks like. So that leaves 4. That leaves 7 and 9 here. This is a 1-4 pair. Being told 2 in box 2 is placed. Looks like it. So this 2 looks up. This 2-3 pair sees here. This 2 sees these 2 and this cell by Knight's Move. So that leaves just here for a 2. So that means 2's in one of these. And then a 7 in row 9. This 3-7 pair keeps out of here. This 7-8-9. Yeah, okay, so these 7's line up, meaning 7's in one of these two. Oh, this 2C's here. Now we have 2, now we have this pattern, which eliminates 2 from over here. So this can't be a 2. Now we have, okay, so this is really interesting. So think about this column. Where does 2 go in this column? It's one of these two. And that does see these two. So this cannot be a 2, and now there's only one place for 2 left in this box. It's always weird how that happens, but nice to move the spooky like that. So let's see here. This cell sees this whole 6, 7, 8, 9 quad, doesn't it? Oh no, it doesn't see this one. It sees 3 out of the 4. Darn, that's almost useful. Okay, never mind. Doesn't see this one. So it could be the same as this one or a 5. Eights can be one of these two. Or one of these 4. What are we seeing here? Yes, okay. So 8 in this box is in one of these 4 cells. If it's one of these 3, that sees this 8, but also this sees this 8 by Knight's Move. So no matter what, this cannot be 8, or you'd have nowhere to put 8 in this box. So that does force an 8 here, which means 8's up here. Good spot, Peter. Okay, so this 9 looks up, and this 7-9 pair actually sees this cell. So 9 is in one of these two, and these 9s now look left, making this a 7 and this a 9. So now this 7 sees here and here and here, making 7 one of these two. Now these 9s look here, this 9 sees here. I'm seeing 9 in one of these two, I'm not sure how it's placed. Oh, this 9 sees here as well, so that does place the 9. That sees over here. Seven's in one of these. 9's in one of these two. But these 9s look left. That places this 9. What are we doing on 9s? Don't we have the same thing? Yeah, now we have the same thing with 9s, where 9s are in these 4 cells in this box. And all 4 of them see this 9. So that places this 9. Now the 9 joins the 8 up here. So these are from 5, 6, 7. Trying to look. So how about 9s now? This 9 sees back up to here. Basically, 9s are in these cells. I don't think I can resolve that. Markrab says 3 in box 4 is interesting. Yeah, it's placed. These 3 is just C in. And that looks over here, places this 3. So we're looking at where 8s can go in row 4. These 8s look up, this 8 looks down, and this 8 sees this one. So 8s are limited here, and this is not an 8. There's lots of knights move spots in this puzzle. Not surprising given how minimal it is. Ice cube spots something in column 8. There are 6 cage cells, which must be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so these are from 1 through 6. These are from 1 through 5. Yeah. So this can't be a 6. In fact, I guess the question is, where do 7, 8, and 9 go in this column? These can't be 7, 8, 9. This can't be 7, 8, 9. And these can't be 7, 8, 9. So we could have, from the start, done that. 7 is placed in this box. The 7 looks over and the 7 sees here. Places that 7 also. Oops, got to remove the 7. How are we doing on 7s then? This 7 sees down, making that an 8. So that's not an 8 and that's not an 8. And these aren't 8s. That 8 sees over, making this an 8. That 8 sees up here, making this 1 an 8. Yeah, we just have an X-wing on 8s left. This 7, 9 looks left. And this is a 3 and a 7. Oh, this 7 sees down, making that a 9 and a 7. People in chat are saying this. I'm sorry I'm not giving credit, but... let's see. I need a 2. No, I don't need a 2. Luckily, I don't need a 2 because I couldn't find where to put it. I have 1, 2, 3. I need 4, 5, 6, 7 is what I need. That's not a 7. 4, 5, 6, 7. I don't know much about those numbers, actually. Oh, this 7 does see over, though, so that's maybe helpful. Oh, 6, 8, 9 triple means these are not 6s. So this is 4, 5, 7. I'm not seeing any knights moves. Oh, this 8, 9 pair sees down. Oh, no, we have the 9. Never mind. We have our 9s done. Oh, this 9 sees up. 9s aren't done, but they're not finishable right now. Caleb, 8 in box 5. True. 8 is placed. Okay, so for this column, we have 1, 2, 3, 4. We need 5, 6, and 8. So the 5s are in one of these two. This is not an 8. In fact, this is 4, 5, 6. We need a 3 here with the 4, 5, 6. Sixes are limited to these two cells, which see these two, in a similar way to what we talked about before. So this can't be a 6, or we'd have nowhere to put 6 in this triple. So this has to be the 5. That's not a 5. And so this is a 6, 8, 9 triple also. Oops, I put 3. 6, 8, 9. Not an 8. 6, 9 pair. So these are from 1, 2, 3, 4, 5. This is not 2 or 3. It's not a 1. No idea about this one. Oh, this isn't a 2. This can't be 3. Is this 1, 4, 5, 6? For the row? That can't be a 1 though. We have 1, 2, we need 3, 4, 5 here. Being told there's a 3 in box 8. It's in one of these. Okay, there's a 3 in box 8. It's in one of these. That looks up, placing this 3. This column has 1, 2, 3. We need 4, 5, 6, and we have 7, 8, 9. This does see a 5 by Knight's move, true. Meaning one of these two for the row is a 5. So these cannot be 5s. It's interesting that this forms a 4, 5, 6 triple. They all see each other. Maybe I should color just for fun here, just to see if that means anything to me. This cell here can't be orange or blue, so it's either purple or 7. Can it be a 7? I think it could be. 7's in one of these. Oh, this cell does see blue and orange though, so that's purple. And so now this sees the whole 4, 5, 6 triple, so it has to be a 7. That's a 4. That's a 5. These are not 5s. I don't need 5 colored anymore. Very cool. So now this can't be 4. Okay, so we got 1 and 5. These can't be 4s. Oh, purple sees a 4. That cell was a 4. That's not a 5. Something's extra here. Oh, not a 4 either. So that's 7. That's 6. That's 5. That's 6. 5. 4. This isn't 4 or 6. So that's 5. That's 4. Clearly something peeks in here. Alright, well, let's figure this out. So the box needs a 1, that's here. It needs a 2, that's here. Has a 3, it needs a 4. 4s go here somewhere. It needs a 5. Let's do it this way. Let's clear our corners. It needs a 5, which goes in one of these two. And it needs a 6. Do I have anything looking in there? No. This is a triple. So, hold on. This can't be 7. Actually, we placed 7 in this box, which places 2 and 3. So this triple should let us know what, yeah, 4 needs to go in the box somewhere. It goes here. Now we have 1, 5, 6 here. This 6 sees here. This 5 sees here. That's a 1. 5, 6 pair sees over here. So that's 2 and that's 5. 6 sees here from here. 1 sees both of these. That's what we were saying. One of these had to be 1. So there it is. 4, 6 pair sees these two. So this is 5 and this is 6. This 4 is a really powerful nice move where it sees this whole plus, but that doesn't actually help. This can't be 3. Oh, this 6 sees in here. So that's 8, 9, and 6. That's a 6, 9, and 8. This can't be 2 or 5. So we have a 1, 3, 4 triple. That leaves... Okay, so 2, it goes in here somewhere. Oh, 2 goes here, actually. That looks up, making 3 and 2, 4 and 3, 1 and 4. This is not a 4 or a 3, so that's a 1, 4 and 3, 6 and 4, 5 and 6, and we're done. Sweet. Thanks, Blobz. That was fun. Very nice Knight's Move puzzle. We got to use some of the fun Knight's Move patterns without without having to do the annoying ones. So that was good. You can definitely make a very annoying Knight's Move puzzle. This does not qualify. This was a nice one. I don't know if the 4, 5, 6 thing I did here was necessary, but it was super fun. I enjoyed that. Some good use of coloring that resolved itself. Hey Lava, how you doing? All right, I'm going to prep the next puzzle. I'll see you, Katie. Okay. Puzzle. Is ZegreS here by any chance? Rocky Protect. This one was on CTC? Oh, I didn't watch it, so. Alrighty. Oh, you guys get to watch me struggle with it then. I do believe that I gave ZegreS the option Yeah, ZegreS said to still do it, so even though it was featured. All right, this is called Parity Mirror. It's by ZegreS. We have normal Sudoku rules. Digits don't repeat along the marked diagonal. So this blue main diagonal here that goes top left to bottom right, it acts like a row, column, or box where we're going to have the digits 1 to 9 exactly once. Marked diagonal reflects odd, even parity on each side. So, for example, if row 6, column 2 is odd, then row 2, column 6 is odd. Now that's an interesting rule. So we can see that it reflects across this diagonal here. So I think that just means we swap the chords. So also like row 3, column 6, if that's even, then we would just swap the coordinates and we'd say, no, that's not true. Sorry, it's because I said something different than I marked. If row 7, column 6 is even, then row 6, column 7 is even. So yeah, we just swap the chords. You can see it visually. Sort of the other diagonal, it's going to mirror across. So that's how that rule works. And then the purple line, okay, so we have standard arrows. So these two digits, you sum them, and that is filled in the circle. So if this were 5 and 3, those would sum to 8, so we'd have to fill in 8 in the circle. And then standard Renbans. So digits on a Renban are consecutive, but in any order. So say this was 2, 3, 4, 5. 2, 3, 4, 5 is a consecutive set of digits. We could put 2, 3, 4, 5. They're in any order we want, but as long as that all the digits are consecutive on the Renban in some order, we're fine. What I can't do is 2, 3, 4, 6, because the 6 is not consecutive with anything on the Renban. And those are the rules. I feel like that's enough. Took Simon 2 hours. Okay, well, hopefully it won't take us 2 hours. But we have 2 hours left in the stream, so. Well, we can do some easy stuff first. This has to sum to at least 6. So let me think about that for a second. Let me see if there's any other low-hanging fruit before I use that logic. Here, this is at least 6. Well, the diagonals don't reflect at all, right? I'm not sure what you mean. These cells don't reflect anywhere. You need to reflect. Oh, I see. So if I gave, in terms of parity, we have I don't see it. There's always at least one even. There's 1 or 2 evens on a 3-cell Renban, which should be fairly obvious. And so if we used, okay, so we have an even number of evens outside the Renban, and there's an even number of evens total. So there must be an even number of evens on the Renban. So this is, both of these Renbans are 2 evens and an odd. I get that. So I don't know how to mark that. Means they can't be 1, 2, 3. So they're 2, 3, 4, 4, 5, 6, or 6, 7, 8. And so we can't use 4, 5, 6 because that would prevent the other Renban from being either 2, 3, 4 or 6, 7, 8. So we're going to need 2, 3, 4 and 6, 7, 8 on these Renbans, which leaves 1, 5, and 9 here. We know this can't be 9 because it's on an arrow. So it's odd. These are all odd. If this was 2, 3, 4, I guess I could put 1 and 5 on here, and that would still be low enough. Well, this can't be 7 or 8. We can at least say that. So these would never be 6. If this was 6, this would be 1, 2, but that doesn't seem like a particularly difficult thing to do. So this, wait. Yeah, we can't put both 2 and 4 on this arrow. We can only put 1 of 2 or 4 on this arrow. So, and the only way to put 3 on this arrow is here. Okay, so, hold on. What am I thinking? We can only put 1 of 2, 3, 4 on this arrow. Wait, no. That's not true either. How do I think about this? How would I put 1, 2, 4? I think 1, 2, 4 is the easiest one to prove wrong. How would I put 1, 2, 4 on this arrow? It would have to be like this. And then these would both be 3. Right? We just have way too many 1, 2, 3, 4s in the box. So this cannot be 7. How would I do 1, 2, 3 on this arrow? 1, 2, 3, 4, 5. That's no good. 5 cells for 1, 2, 3, 4. That doesn't work either. So it's not a 6. Ooh, is this lunch? Thank you.
Do you know where those cord ties are?
I don't know if they're in here somewhere. Exact same logic here. How would you make 8? There'd have to be a 1 on here. We could be 1, 2, 5. We could not be 1, 3, 4. So we'd have to be 1, 2, 5. Hey, Sergey. Ooh. That's a very good point, Garyon, because they could both be 8, but they can't both be 9, because that removes 9 from box 5. So, So one of these is going to be 6, making it a 9. So this is an 8-9 pair. The one that's 8, how do we make 8? Well, we would need a 1 on it. Let's say this one was 8. That means it's not 6. That means we have a 2, 3, 4 in here. So we'd have to be 1 plus the 2, 3, or 4. So we could be... We couldn't be 1, 2, 5. Well, if we could be 1, 1, 2, 5 this way. Or we could be 1... We couldn't be 1, 3, 4 because you can't use 3 and 4 on this arrow. And we couldn't be 1, 4, 3 for the same reason. So we would be 1, 5 with a 2 here. So this is a 2 or a 6, always. So we can kind of reduce this here. And the 6 is with 1, 2. And 8 is with 1, 5. Yeah, 2 is always used. Oh, this is pretty small now. I want to think about this. So we always have an even. This can't be 8 or 9. That seems intentional. How small can it get? 1 to 1, I guess. But I don't know if 1 to 1's possible. This would have to be 5 through 8 or 6 through 9. Oh, there's a 2, 6 pair here also, so this is not a 6. What are you saying, Philipp? 7 would be 5, 1, 1, but 1 is in box 5 already? Okay, we're saying this can't be a 5. Okay, if this is a 5, we'd have to add the 7 exactly. That means double 1 here, but now we have too many 1s in the box. So this is not 5. This is a 1. Okay. So whatever parity this is, this will be the opposite parity of it, which means this is the opposite parity of it. So we're going to have an odd and an even plus an odd, making the answer here even. So doesn't this have to be 4? Am I crazy or? That seems right to me. And then that's forced to be 1 and 2, which we know the parities of. I may still be crazy, but not for that reason. All right. This has to be at least 4, so this is 5 or higher. This is 5, 7, or 9. And then, yeah, this even transposes here. Oh, and we got this 2, 6 pair here. So this is 4 or 8. 4 seems hard, but is it impossible? 4 would be a 1, 3 pair on both of these. But a 1 here and a 1 here. I'm actually not sure. Ah, this sees an 8, 9 pair also. So this is 4 or 6. So this can't be 9. Oh, Philip, you see something? Oh, yes, that's definitely true. That breaks. So if this was 1, 3 and this was 1, 3, then there'd be a 1 here and a 1 here. And so now which of these two is a 1? Neither. They both be 3. So that doesn't work. So this has to be 8. Which is the less interesting of the values, but... Good spot, good spot. I didn't see that for some reason. So that means these can't be both 1, 7. It's not that interesting, but... Ah, the 8 can't be 2, 6. So we're from 1, 7 or 3, 5. Whoops. Which is all odd, isn't it? Which transposes to these two. Right? And they can't both be 1, 7. So one of these is 3, 5, but we don't know which. Oh, true. This Renban's going to have two evens and 2 odds, so these two are even, which makes these 2 even. Yeah, at least one of these is 3, 5. Well, no, I don't think they can both be 3-5, can they? For the same reason, it would put a... Doesn't there... does one of these have to be a 5? These can't both be 1, 2, because then these would both be 9, and then we know that breaks. So one of these is a 5, I just didn't mark it. So these can't both be 3-5 for the same reason. We'd end up with 5s here and here. Oh, no, but... Oh, no, that's not true. That's not true. That's why I didn't mark it. Only one of them has a 5 there or there, not both. That's why I didn't mark it. Okay, so... Oh, I forgot to mark these as even. May as well. Is it interesting where these go? It might be. They go here and here. Let me gray those. And then these two go here and here. Let's gray those as well. Maybe I'll pick a lighter gray. We know one's odd, one's even. What did Eagle say? Look at column 8. How many evens? Ah. So we know a two-sol arrow always has an even in it. In fact, one of these two is going to be even. So that's all our evens. Meaning this is odd and this is odd, so it cannot be 2. We can't do the same in this row. This odd goes here, making this odd, and this odd. We know there has to be a 2 somewhere. That goes here. That's a 6. This is the 9. This is the 8. These are not 5s. Very nice spot. So this is 6 or 8. And this is... Well, if this is 6 or 8, can we really put a 2 here? 6, 5... No, we can't. This is also 6 or 8. But it's not a 6. So this is 8, this is 6. And then we've got... definitely a 7 in here. And it's with a 5 or a 9. But this is not a 9. Let's clean up these Renbans here. That's not a 2. That's not a 6. 8 is even. 9 is odd. So this 8 comes down here. That's even. That makes this one odd and this one even. Which makes this one even and this one odd, which is good because that 8 is... This is odd. The 9 looks down, thank you. 5 and 9. That's not a 5. Means that's not a 3. These two cells are even, true. One of these is even and one of these is odd. And those go here. So whatever parity this is, let's say that's green. These are both the other parity, purple. Six and 8 in box 9 are placed. Oh, true. The 3-4 pair gives us the 6 and the 8. Look at box 1. This one sees a 2, 4, 6, and 8, so that has to be odd, which means that one's odd. So that's a 1, that's a 2. Means this one's even. Oh, and that's super good. This sees 2, 6, and 8. That's 4, that's 2. This now can't be even, so it's odd. So greens are odd, and these are even. I'm wondering how these evens affect this box here, but I'm a little bit... I think that's just my brain tricking me. I'm being told there's some arrow. This arrow? Oh, column 2. Ah, this can't be 1, 7. So that's 3, 5. So this is the 1, 7. We know the order. No, it's not the 1, 7. What am I talking about? This is 1 and 9. But we still wait. This is 1, 9. We don't know. No, it's not 1, 9. It's 7, 9. Oh my gosh. What is happening to me? Okay, this is 8 or 6. 2 in this box. It's one of these two. This is 3, 5, or 7. Actually, 1 in this row is here. So this is either 3, 6. Can't be 3, 6. Does that mean this is 5, 4? Because it's not 1. This can't be 1 or 3. Oh, it could be 5 or 7 with this being 4 or 2. That's how that works. Well, that makes a 5, 7 pair, making this one a 3. Let's see. Okay, so that's a good point. If this cell were even, then these two would have to be odd, making these two even, and then we'd have 5 evens in this column. So this cell is odd, and that transports down to here. It would have been the same logic on that one. This Renban makes me think there's something restrictive, but this is 2, 6, or 8. This is 2, 4, or 8. Oh, this is a 7, 9 pair. What? Florian saying the 7, 9 pair in box 9 excludes 1, 7 from the 8 arrow. What? Okay, well this is 1, 7, or 3, 5. That's not 5, so that's not 3. That's not 1, so that's not 7. So if this was 1, 7. Oh. That's weird. Okay, the less weird way of saying this is there's a hidden 3 in the column. That's the less weird way of saying this. This is a 3, so that's 5. That's 1. That can't be a 5. That's a 5. This can't be 3, 5. 1, 7 makes that 9 and 7. So that's 9, that's 7, that's 5, that's 4. This is not 4. Three in row 8 says more crabs. Yes, of course, that's the last odd. This is 7 or 9, can't be 7. So this sees all the odds except 9. I can't put both evens down here because it would be 4, 6. Is there something I'm supposed to be seeing here? Well, first there's a 2 in one of these. But it means that at least one of these is even. This sees 2, 6. So if it was this one, it would be 4, 8. If it was this one, it would be 2, 4, or 8. Oh, the 3 makes this a 2. That's right. Ignoring the Renban completely. 9 in box 7 goes here. It's by Sudoku. Okay, well... I can place all the 9s, you say? Oh yeah, that's 9's placed. That 9 is... Wait, 9's are here. I don't think I can place these two. The box 7-9 mirrors. Box 1... Oh, this one, the box 1-9 mirrors, that's for sure. So this is a 5. There's a 5 in one of these two. Oops, not both of them. There's a 5 in one of these three. Ah, there's a 5 in one of these two. And not here. So this is a 5 in the box. Wait, is that true? That might not be true. There's a 5 in one of these two. Something mirrors to box 3, you say? What are you guys saying? Oh, this 9 mirrors here, making this a 3 or a 5. Ah, but the 5s look in, making it a 5. So this is a 3 and a 2. That looks down now, giving us the 4 and the 3. Finally disambiguated those. So this triple is 1, 7, and 9. That's not 9. So this is odd. Then this is odd, making this odd and this odd, making both of these even, making both of these even. These are 2, 4, 6. That's not 2. These are, this is not the 5, so oops. That's 5. These are, this is the 6, and these are 4, 8. Which does not appear to be resolved. This is 1 or 7, but we know what it is. It's a 1. That's 7, that's 1. Okay, what do we have now? 4 in box... Ah, this 4 places the 4 here. I need a 6. And that's with whatever's left of 3, 5, 7. Ah, and I need a 3. This is a 3, 6 pair. Could have just looked at the row. We know which way they go. Oops. And that parity helps a lot, because the 3 comes up here, making that also a 3, making that a 2. That 3 makes this 5 and 7. That makes this a 6, unsurprisingly. And then this is a 3. So that's a 5. 4 in this row only goes here. That's 6 and 2. Um, 2 in the row goes here. This is 7, this is 1. Eight, 6, 7, 9, 9, 7. What? I guess I'm gonna have to watch the video to see what he missed for so long. We need a 4, and we need a 3. So this is filled. With an 8. That's a 6. So that reflects, making that a 4. Oh, I could have reflected them earlier. That's okay. We're getting this done. We're just cleaning up. Diagonal's done. This is something, a 1. This is even, and it's a 4. Now I better be careful not to accidentally finish the puzzle before I finish the coloring. This is 8 and 4. Yeah, this one's going to be even, making this odd. This one's going to be even, this one's going to be odd. Okay, good. Phew. All right, that's a 2. That's an 8. That's a 3, and that's a 7. Very nice. Oh, Simon did it in 45 minutes? Okay. So, yeah, we usually match Simon's solve times. As a group, we match his solo solve times. Who said it was 2 hours? They were just trying to strip me up. You guys trolling me all the time. All right. Well, we certainly have time for another, so I'll be right back. I'll prep that. Oh, right. I have a super supporter puzzle. Let's do that now. Which someone kindly reminded me of. I need a better way to track that. Now that I actually have several super supporters. All right. I hope Peter's still here. Looks like he is. I love it. All right, so Peter used his Super Saiyan powers to skip the queue. So we are doing his puzzle today. Thank you so much, Peter, for being a super supporter. And if you want to be a super supporter, it's the highest tier of membership. You hit that join button. And if you choose the highest tier of membership, you become a super supporter, which has all sorts of perks, not the least of which is queue skipping. So you submit it, And as soon as I can get it tested, I do it. So you don't have to wait in line. And of course, it's thematic that he used Super Saiyan powers for this, because this is called It's Over 9,000! It's by Peter. As I said, Vegeta, what does the scouter say about his power level? The bet cell is row 1, column 7. Will there be a 10k sub celebration stream? That's a good question. I haven't even thought about it. I'm not actually sure when I'm going to hit 10k, because my sub growth is still there, but it's slowed down quite a bit. I'm getting like under 20 subs a day now, so I'm not sure when that 10k is going to happen. And I haven't really planned anything for it, to be honest. Well, we'll try to get something going. Maybe just submitting puzzles for it or something. Like what Zetamat did for his 1,000 subs. I just haven't had time recently to like organize something with a bunch of hosts or anything like that. I'll see what I can do though. All right. I've already been submitted one, even though I haven't asked. $69,000 in 2 years, 3 years, maybe. Let's see. All right, so let's go over the rules. We have normal Sudoku rules, standard killer cages, so that's a 9. We can just fill it. These sum to 10, these sum to 10, these 3 sum to 10. That's what that means. The green lines are German whisper lines, so as you move along the line, you have to have a difference of at least 5. So if I put a 6 here, this has to be a 1. It's the only digit that's 5 away from 6. But now this cell could be a 7, it could be an 8, it could be a 9. It would be able to be a 6 if it didn't repeat in the box or the row. Hopefully you get the idea there. Purple lines are Renban. These are all constraints we see all the time on my stream. So that means that, say, these 4 cells, because there's a purple line there, they are a set of 4 consecutive digits, but in any order. So say they were 2, 3, 4, 5. Those are consecutive. I could do 2, 3, 4, 5, and that would be perfectly fine. They're in any order you want. They're just all consecutive with each other. So I cannot put, for example, a 6 here, because the 6 is not consecutive with anything on the line. We have a single black dot here. These have a 1-to-2 ratio. The best way to describe that is one number is exactly double the other number. So if I put a 4 here, this could be a 2, because 4 is exactly double 2. Or this could be an 8, because 8 is exactly double 4. And these 3 gray circles are odd numbers. O for odd. All right, let's get started. We know this is a 1, 2, 3, 4. Now the question is, do I want to... I don't think I want to even odd. I think I'll just do 1, 3, 5, 7 here to remind myself those are odd. But I'm not going to color them. I don't know if... Let's see. Let's make this orange and blue for now. And then I'm going to parity color this purple and green. So it's not as long as I thought. For some reason I thought they were connected. I wasn't looking very closely. These are all green. Let me know if I make a mistake. I very often do. And then we can make these gray and these red for now. And now we look to see if there's restrictions on them. That makes sense. Green is not gray. In this row, you only have 4 of each pair of each low heighty. And so we can't make all these green. So we can make gray, purple, and we can make these green. That's helpful. There's a low and a high in the 10 cage. So the last green is used in this 10 cage for the row. This 10 gauge has a green in it and a purple in it. I can mark that. So that means that this one cannot be green. It must be purple. So this one's green. Yeah, that means 5 is in one of these two. So this cannot be 5. If this is purple, it's low. That is green. You can place 5 in box 1 and box 3 via box 7 and box 6. Ooh, okay. This is box 6. Okay, so box 6 has 5 in one of these 3. Box 7 has 5 in one of these 2. So that's a 5. I'll make 5's gray. And then, yes, 5 doesn't go on this line, so 5 is here. That's gray. So I have 1, 2, 3, 4. These can't be purple. So these are green and gray. This one here, we have 1. Okay, so these are 1 of each. This whisper can be colored. Oh yeah, these both can't be green, so these are purple. Because the row would have too many greens. So now these are green or gray. Five in box 9. Doesn't go on a whisper line, so that's 5. Let's mark these. And these. Oh, this belongs to that whisper, so it's just green. True. So this is purple. This is gray. All the odds are used in the row, so these have to be either 2, 8, or 4, 6. Five is placed in this box, making this one a purple. We can't put a 5 on a black dot. So, easily put a 5 on this Renban, though. Yeah, this can be greened for the row. Which means we have 1 of each here. Oh, wait, we have 1, 2, 3, 4. Wait, yeah, we have 1, 2, 3, and then 1 of these is green, which means this can't be green. This is purple, which means this is green. And it also means this one is purple. So this one's green. Oh, and that makes purple blue. Green is orange. So now we know low high. Um, 10 Kage. Can't a 10 Kage have a 7 in it? So we're talking about 9s in this column by more crabs. Can't be in the 10. Okay, 9's not here because it sees a 9. It's not a 5. It's not low. It's not in this 10 Kage for sure. It's not here because it sees that 9. So 9s are in these 3, but if this is a 9, then this is a 1. And what does that do? Where would you put 4 and 6? Because the remaining cell, we could, okay, so if this was 9, this would be 1. We could squeeze a 4 here, but then where would we put a 6? Because the 6 would have to be next to a 1, wherever we put it. And it couldn't be. So that puts 9 in one of these two. Good spot. Breaks the cage. It's 1, 3, 6 or 1, 2, 7. 6 would need to be with 1, 7. Oh, 6 would need to be with 1. 7 would need to be with 1 or 2, and it breaks the cage. Oh. Oh, I see, I see. So if this were a 6, this is obviously a 1. And then now the minimum you can put in this is 2, 3, and that adds to 11. If this is a 7, this could be a 2, but then this would be 1, 3, and that still adds to 11. So this actually cannot be high, it must be low, making this one high. This is 1, 2, 3, 4. Can't be 4 because that can't be 9. So this is 7, 8, 6, 7, 8. Oh, and this, we have all our odds, so this has to be even. This is 2 or 4 because it's low, which makes this at least a 7. This 9 has been high the entire time. It's worth noting there is always a low on a black dot. Usually 2 lows, but not always. These are from 6, 7, 8, but I guess either one could be 6. Rocky Tech. This can't be 6, so it's also 7, 8, 9. This one can't be 4, so it's 1, 2, or 3. But this one could be 4. We have a visitor. Hey, Mavericks. I'm gonna close my door just so you guys don't hear the conversation. Long time no see, Mavericks, I think. This one can't be 4. This one can't be 4 because this can't be 9. So actually the 4 is in one of these two, which looks down, making that a 2. This is not 2, 8, that's 4, 6. Makes that an 8, unsurprisingly. 9 in box 3. Right, we said this can't be 1, 9. So 9's over here. So this is 1 or 3. 3 would require 7, 8. No. So 3 would require 8, 9. What am I talking about? 3 require 8, 9. That seems okay. 9 in box 2 goes here. Good spot. So this is 6, 7, or 8. So there's a 1 here, here, or here. With Knight's move, that means that can't be a 1. But there's no Knight's move, so. Finish box 7. Okay, so that's not a 2 or a 4. One of these is a 3, meaning that can't be a 7. These are from 5, 7, 8, 9. Florian says there's a 4 in box 4. Oh, interesting. Yeah. So where does 4 go in box 4? It's obviously not high. It can't be here or here because that would put double 9s in the box. Can't be here because this would be 9. You can't put 9 on a black dot. Also, it sees a 9. So 4 is in one of these two. And then now we're saying we follow that into box 6. Neither of these can be 4 because of the same issue. This 4 would put double 9 here. This 4 would put double 9 here. So, and then these 4s point right. So this is the only place for a 4 in the whole box. And then we follow that into box 3. And 4 can't go on this whisper line because it would need a 9, and that sees a 9. So this is a 4, 6. That was very useful. That places a 4 here. These are from 1, 2, 3. So is this. Box 5. 4 is in one of these two, in box 5, and so that forces a 9 here. So this cannot be a 9, so this can't be 4. That puts a 4 here. This is from 6, 7, or 8. The 6 in box 2 will force a 1. So this can't, yeah. So first of all, the 6 in box 2. Oh, no, okay. So 6 in box 2 will force a 1 into one of these two, which means this one can't be 1. Is that what we're saying? Yeah. 6 is in one of these two, which means 1's in one of these two, which looks left. So there's a 1 in one of these two, which means this is not a 1. Oh, and this sees a 2. So this is 3, this is 1. These are not 3s. So this is 2 or 3, because it can't be 4. Which means these can't be 6, so they're from 7, 8, 9. That's not a 9. This 9 looks over, and we corner marked the 9, so this is now high and this is low. That makes this the 4. This is 6 and 4. Let's clean up their coloring. This is 7 or 8. I gotta place this 6. Oh, we just knew the 6 was in the 10 gauge, right? Might as well mark these are from 6, 7, 8 while I'm at it. For 7, 8, 9. Oh, this 3 sees these two, thank you. So that's a 3. 1, 2 pair, that's not a 1, that's not a 3. When do these Renbans come in? Oh, the 3 forces this to be 8. Nice. That's 7, that's 9. 7 forces 2. Forces 1 and 2, 3 and 1. 3 forces 8 here. This is now... Oh, still 4 or 6, never mind. This can't be 8 or not. Okay, so where does 8 go in the column? Only goes here. Oh, it saw a 9 also. Probably easier to do it that way. 5, 7 pair looks up. This is either 5 or 6. If this were low, it would be a 3 or a 4. Well, this can't be a 4 because this can't be 9. So if this was 3, this would have to be 8, but it can't be. Wait, can this be high anymore? This can't be high anymore because the only way it's high is 6 or 8. It sees an 8, and if it's 6, that's a 1, and that sees a 1. So this is low, and this is high, making this 6, making this 5, meaning this is not a 5, meaning this is 5. Okay, come on. What am I pressing? Wrong buttons is what I'm pressing. This is 6. This is 7, 8. This is 3 and 5. We know the order. Okay, so this is low, meaning 1, 2, 3, or 4. It's not a 3. It's not a 4. So 1 would force a 2 here. 2 would force a 1 or a 4 here. It can't be. So this is 2 and this is 1. That's not 1. All our lows are done. I wonder if this 10 Kage has been done for a while. This has to be 5 or higher. So this is 5, 6, or 7. Might as well do that. And so even if this is 5, these two would add to 5, making this low. These can't actually add to 5, so it's not a 5. So it is high. A 6, so there's always a 1 here. 6 would be with 1, no wait. These can't, oh yeah, 6 would be with 1, 3. What am I saying? 7 would be with 1, 2. There's always a 1 in here. Right, the not evens, the lows left are 2 and 4 here. We know the order. That makes this a 2. This always sees a 3, so it has to be yeah, it has to be 8. That's a 7. Means that's a 3 and that's a 1. 3 precludes 7. It sees an 8, so that's the 9. That's not a 6. Places this 6, this 1. 2 and 1. Column 9, the 7 looks down. Cool, so 6 with 1, 3. This sees a 1, 3, and a 5, so that's a 7. This is high. This sees a 6. This is 4, this is 6. We can color them low and high. This is at least... Oh, this is just the 9 for the box. This is the 5 for the box. Wait, no, we already had a 5. This is the last low. Sorry, I'm going a little like cross-eyed right now. I don't know why. This is 1 or 4. It can't be 1, so this is 4. This is 1, which is low. That makes this one a 3. Oops. Which is also low. It's weird to mark odds blue, but it's just how I did the puzzle. These have to... By Sudoku, we have 1, 2, 3, 4. We need 5, 6, and 7. So there's always a 6 on this line. I don't think a 6 looks down. Yeah, the Renbans have just been ignored completely. These are also 5, 6, 7. That's not a 5. So these two are high. 6, 7 pair. So that forces this to be a 5. No longer ignored. That's a 5, that's a 7. We can color them. 5 is gray, 7 is orange. So this is not a 4, so this is a 8. These are high also. That's 6, that's 7. That's 6, that's 7. I think the Renbans were there for the face more than anything. To get a good picture going. Which I fully support. This one's also low, and it's a 3. Okay, good. We got the coloring done before the numbers. Saved. 7 sees up. And, oh, we still have these two. We gotta get these colored quick. Before the puzzle finishes. Right, that's high, that's low. Okay. 3, that's 1 and 3. This one's a 2, and this one's a 7. Oop, this one too. That's a 3. That's always a 3. Congrats to Bremster. Yeah, it's Vegeta. So we got the Scouter and a mouth or something. Thanks, Peter. Cool picture, cool puzzle. Oh, Bremster is here. Congrats, Bremster. You couldn't sleep? Well, hopefully my stream will help you with that. It is well established in DBZ canon that Vegeta wears purple lipstick. True. Is Goku next? Alright, give me one moment to get the next puzzle going. Alrighty. Anyone know if Philipp Huber is in the stream or on Discord? Not sure how to let Philipp know. Oh, Philipp is here. Nice. Oh, sorry, I'm getting a weird like cross-eyed thing right now. Just give me a moment to rest my eyes. Okay. Oof. Let me sit properly. Maybe that'll help. Okay, so I haven't read the rule set yet, but it sounds like it might be interesting here. These are called Krop Kages 3 by Philipp Huber. We have standard Sudoku rules. Standard killer Sudoku rules apply, except no cage totals are given. So what that means is we're not given the cage totals, but there are cage totals where the digits sum to some total. But also digits can't repeat. Digits can't repeat in a cage. So if I put a 2 here, normal Sudoku rules would allow me to put a 2 up here, but I'm not actually allowed to. Let's see if I can. Is there conflict checker is on? Okay. So I can put, I normally by Sudoku I could put a 2 here, but that would repeat a 2 in the cage, and that's not allowed. So I can't actually put a 2 there, or there, or there. We have Kropke rules, but they don't apply to cells. Standard Kropke rules apply to cage totals. So cages connected by a white dot have consecutive sums. So whatever these 4 cells sum to is a consecutive number with what these 3 cells sum to. And then also cages separated by a black dot have a 1 to 2 ratio, which means whatever these three sum to and these two sum to have a 1 to 2 ratio. One of them is exactly double the other. Let me see if I can give an example of that. So for example, this could be 9, 7, and then that sums to 16, and we could make this sum to 8 by making it 1, 2, and 5. And so this would satisfy these cages, where this cage was double the sum of this cage. And then now this was 8, so we'd want to make this sum to 9, but that would break because we can't. All right. All possible dots are given. So, for example, this cage here and this cage here cannot do that. I can't do 9, 7 here and 1, 2, 5 here, because that would make this sum to 16 and this sum to 8, and we would expect a black dot between them, and there isn't, but all the dots are given, so that would break. So, and this is the bet cell here, so go ahead and bet on that if you haven't yet. All right. Well, there's an interesting place to start if we would like to, which is that this sums to 45, because we know that the digits 1 to 9 are in this box, and they sum to 45. That's the secret. Don't tell anyone except your best of friends this secret. Let's see. I don't think we have to worry about a black dot on a 45 or a white dot, so I don't think that does anything. This is a single digit value. Okay, maybe we can start here. So these all sum to 45. And we can kind of parity color the sums here, because these are all connected to a white dot. So whatever parity this one is, green parity, these all share the same purple parity. And so we know that because there's 4 cages here, these are going to sum to an even number, which means this has to be an odd number. Now, how small could the odd number actually be is an interesting question. So if these all sum to 10, this could be a 5 even. Oh no, if these all sum to 10, this would have to be a 9. And that doesn't work. I don't think this can be 9. So if I put a 9 here, well, I guess we'd have to use 8s and 10s in some way. How do I want to think about this? But we know this. We know that these are odd cages and these are even cages at the very least. Why can't it be smaller than 9? Eight, 8, 10, 10. Okay, yeah, so if this is 7, then all of these would be 8 maximum. And 8 times 4 plus 7 is, what? Well, way lower than 45. So this does have to be 9. And then, so we have 2 sums of 10 and 2 sums of 8 is the only way to do that. So we know this has an odd sum and this has an odd sum. We know that black dot always has an even on one side or the other, so that's got an, we're going to be doubling the odd to make an even. Yep, there's another stream tonight at 7. You can see the time above me. At 7 o'clock, we are doing a word game stream. So this is consecutive with both of these cages. Which means it sums to 9 or 11. Or 7, I guess? This is even. So this is double the sum of this one. It maxes out at 16 because it's even. So this adds to 8 maximum. So it adds to 7 or 9. No, it can't add to 9. It adds to 7. So this is 1, 2, 4. Okay, that's helpful. And so this does add to 14 now. Which has to be 6, 8. Oh no, it doesn't have to be 6, 8. It could be 5, 9 or 6, 8. If this summed to 9, then this would have to sum to 18. You can't do 18 and 2. Now that we know this is 7, we know both of these are 8. So these two sum to 8. Which means that there's a 2, 8 in one of these. How many ways are there to sum to 8? We could do 1, 7, we could do 2, 6, we could do 3, 5. Orange in box 8 is a 9. Right, so this is a 10 cage. Which means this... why can't it be an 11 cage? It's not a 7 cage. Oh, 4 can't go in an 8 cage. So we have 2, 8, and 4, 6 down here. Oh, this is consecutive with an 8 and a 10. The only number that fits is a 9. So this adds to 9. Maybe I'll corner mark a 9 up here to remember that. And then this one sums to 18 then. 18 and 3 does have some optionality, but that means that all three of these, both of these cages together sum to 27, which means these 3 cages sum to whatever 40. I'm gonna pull out a calculator because I think we're gonna be doing a lot of mathy things. How's that look? Not quite good enough. There. So we're gonna have 9 plus 18, which is 27. 45 minus 27 is 18. So these 3 sum to 18. Also. I'm not gonna be. This covers some stuff. I can't put the calculator there. So there's a few things we could point out here because of all the dots being given. We can't make this a 1, because if it was a 1, this would have to be 17, and that would be consecutive with 18. Neither of these add to 9, because again, that would be half 18. Can't be 8 or 10. Couldn't be anyway. This cage sums to 14, right? So this can't sum to 7. Well, okay, so these 3 together sum to 18. Okay, 2 with 16 seems okay. 3 with 15 is no good because that's consecutive with 14. 4 with 14 seems okay. But 5 with 13 would be consecutive with 14. 6, what are we adding to again? 18? 6 with 12? 12 seems okay. 7 with 11 seems okay. But we can't do 8 with 10 because 10 would be consecutive with the 9. So we're down to 2, 4, 6, or 7 here. Oh, but 6 with 12 would be, we need a black top between these two, so that doesn't work. We need to make sure not that this cell's not 90 also. Let's see. Do we need to ask where the 1 goes? Because we know this adds to 18. So if the 1 were in here, it'd be 189. That seems doable. Can the 1 go in here? The lowest this can be with the 7, lowest this can be is 11. The 1 can't go in here. The 1 doesn't go in this 18 sum. Because again, it would be 189, and we already rolled that out. Can I roll out 189 from here? Or 126 from here? Well, it would be 126 or 135. I don't know if I can do anything with that yet. All right, so now we could do box 1, I guess. So five is the obvious number. That just makes all of these 10. But let's see, it could be 6. Can it be lower than 5, I guess, is the first question. No, because then even doubling would be 8888. That's no good. So we have to be 5 or larger. 6 could be... With 6, we would need to add to 39. And... so we'd be adding to 39. We could do 12 and 12 and 12 and 3. That would work. With 7, we'd add to 38. We do 14, 14. That's not possible. Oh no, we can do 7. If we do 7, we do 888, 888, and 14. With 8, we do 7, 7, 7, 16. Oh, it's a black dot. Okay, I wasn't thinking about that right then. Certainly can't put a 7 on a black dot. Would 8 work, though? Right, we have to use 4s or 16s. That's not possible. I don't think we can do 8. So I think 5 or 6 is correct. Okay, so what people in chat are saying is if this is a 5, that makes this a 10 cage, which would mean that this would have to be either half or double 10. It can't be a 5, because 1, 2, 3 adds to 6, and it can't be a 20, because 9, 8, 7 adds to 24. So this can't be 5, so this is 6. Which means we're going to need a 1, 3 cage using the 1 and the 2, because 12 can't have a 1 or a 2 in it. So we're going to have a 1, 2 cage and then 3 12 cages. Wait. Yeah, why are people saying it can't be a 20 cage? Oh, it can't be a 20 cage because it's consecutive with a single digit cage. That's why it can't be a 20 cage. I gave the wrong reason. I'm getting a little tired. This is the last puzzle. It's 6 so that this cage works. So this can't exceed 10. It's going to be connected to a 12 cage no matter what. So the question is, can it also be connected to a 3 cage? Only if it's a 6. But even just a 12 cage on its own, it's got to be a 6. This has to be 1, 2, 3, and then this is 5 or 7. So then this 3 cage cell can't be 6, or it would need a white dot. So this 3 cage cell also sees a 12, so it adds to 24. That has to be 9, 8, 7, which actually makes this a 5. And this can't be 7 anymore. That adds to 24, then this adds to 23 or 25, which with 4 cell cage is not hard. But maybe we can do some math here. So 45 minus 24, the remaining cells add to 21. So they're 1 through 6. No, I don't know if I can do anything with that. I was thinking this sticky outy bit. Hold on. No, I'm not sure. But we don't know what this adds to is the issue. This can add, okay, well, okay, maybe this is the important thing. These 3 add to, at most, 4, 5, 6 is 15. But we got to get to 24 at least, or 23 at least. So 23 minus 15. So this is an 8 or a 9 is the point there. Oh no, this is... We can only get to 23, making this an 8. And this is 4, 5, 6. Oh no, but it could be a 9 if we put a 3 in here instead, but it always has the 5 and 6. This can't be 6. Okay. So this has the 1 and the 2 for sure. It can't be 3, 5, 6? Why not? Okay, let's take a look. So 45 minus 24, 3, 5, 6 sums to 14. So if this was 3, 5, 6, it would sum to 14, and we'd have 1, 2, 4 left over, summing to 7, and then they'd need a black dot. So it is 4, 5, 6. Nice catch. That's an 8. This is 1, 2, 3, adding to 6. Oh, but no, but the cage itself is bigger. No, that's not true. It can be 3, 5, 6. No, I don't agree that it can't be 3, 5, 6. I think it can be. All right. But this is 6 or 7. I don't know what that does. This 5 stays down here, making this 6, 8. So this is a quad. Maybe that's helpful. 3, 5, 7, 9. That's not 5. Right, the 9 cage needs a 1 now, because if it were 2, 3, 4, it breaks this cell. That places the 1 up here. Places this one. I'm not able to label these sums. That's really unfortunate. Can I just do that? Okay, so this isn't 1, 2, 6. Okay, so maybe I will. Now I know that this is 1, 3, 5. I can just remember it's 9 by doing that. Can't be 1, 2, 6 because the 2's look down. 1, 3, 5 eliminates 3 and 5 from here. These 5s look down. Okay, that's fine. Oh, this can't be 7 or 9, so this is 3. So this is 4, 6, 8. This is not allowed to be 4, 8, because then we need a black dot with the 6. So it always has a 6 in it, which means that's not 6. Oh, and that sees a 6, so we can place the 6. So this adds to 10 or 14. If it added to 10, we'd be placing a 5 here. Um, oh, I see. If this was 10, it excludes both 5 and 9 from both of these cells, making them both 7. So that's no good. So this has to be the 8. And now that adds to 14, meaning none of these can be 7. That places this 7. 7 now goes in one of these two in the box. That's a 4. All right, we have roping in this stack. 135, 135. So this is 135. With 3 and 5, we got to use the 6 here. So that does put a 9 here. This is not a 9. So this is 1, 2, 4, adding to 7. This is a pair now. We have 1, 2, 3, 4, 5, 6. We need 7 and 9. This is a pair now. 2 and 4, it looks like. Do we know the order? What's this add to? 7, 14, 17. All right, this 10 plus 7, 17. So we just have to avoid 34s. That's not an issue. Oh no, we have to also avoid 18s and 16s. Also doesn't seem problematic. This is a triple now. We have we need 2 and 4, and then 6. Okay. Right, so that makes this a 6. That's an 8, because we are roped. And this is 7, 8, 9. We knew something about these sums, but I forget. Because it's so hard to notate. That sums to 9. That sums to... So this sums to 18 then, right? Has to sum to 18. So I can't... I don't think I can use the 6 here. The minimum this sums to is 15. I mean, I have to do 2. 7, 8 is 15. I only get 3 more, so that's a 2, that's a 4, that's a 6. And then these two sum to 16, which is 9, 7. So that's an 8. That works. I don't think I need these colors anymore. I don't think they're helpful. This can't be 6. What do these add to? 8. So this can't be 2, 6. This can't be 6, that can't be 2. This can't be 4, so that can't be 6. This can't be 2, 8 at all, so that is 4, 6. This is 2, 8. That's not a 2. This sees a 2 also, so that's 8 and 2. I missed a color. This was never going to be 2, 5. Wait, what are we adding to? 8? This is never going to be 2, 7, I guess. What's going on here? This adds to 8. 1, 3, 5, 7. What was it that I eliminated? I don't know. We have a 1, 3, 5, 7 quad here. So, oh, the 7 goes in one of these three. So that's not 7, so that's not 1. This is a triple. We need 2, 4, and 9. It's not 4. Being told box 6 has a lot. Well, we can pencil mark it. So, along with the other 7, 9, we need a 3 and a 5. And then along with the other 7, 9, we need 6 and 8. These aren't 9s. 7, 9 can't repeat at all in the cage. So this is actually a 3, 5 pair. This adds to 7. This can't be 9. This can't be 8. Is this cage total interesting? 24? I don't see why. These kind of act, The 3, 5 pair resolves to cages in box 9. Right, because these add to 8, so they can't be 3, 5 anymore. So this is 1 and 7. 3, 5 pair here. I think this can't, can this be 7? This can't be 7 because it sees the 6, 7, 8 here. So now this can't be 7. That's a 6, 8 pair and a 7, 9 pair. This can't be 7 either, so that's 9 and 7. Did I do that right? Let's see. Anything next to a 6, 7, 8 can't be a 7. So no matter what, it sees the 7. So neither of these could have been 7. And now nothing next to a 6, 8 can be a 7 either. And then the 6, 8 pair just makes this 9 and 7. Okay, and that's 9 and 7. 7 makes this 8 and 6. 6 can't be with 3, so that's 5 and 3. Oh no, that doesn't work that way. Hold on. I can't use that 7 there. I gotta be really careful. Right, this is 9 and 7 though. 9 can't be with 8, so that's 6 and 8. But then I can't go into this cage. I need to be careful. 6 does see down though. 4 and 6. 7 is 9 and 7. This is not a 1. I wonder if this is interesting, because we're down to what, 2, 3, 4, 5? We know this adds to 7. So this can't add to 6 or 8. So it's not 2, 4, it's not 3, 5. We already knew that from that though. Oh, it can't add to 7 either, so it can't be 3, 4. So it has to be 2, 5. 2, 5 is the only combo allowed. So that's 3, 4. No, wait, not 2, 5. Hold on. 2, 5 still has to 7. There's one combination left. 2, 3 maybe is the combo left that it's allowed to be. So it could be 2, 3. That adds to 6. That seems... Oh, no, wait. It can't be 2, 3. Wait, no, sorry. 2, 3 adds to 5. That's okay. It can't be 2, 4 because 6 is disallowed. It can't be 2, 5 because 7 is disallowed. So if we're going to use a 2, it's going to be 2, 3. 3, 4 adding to 7 is bad. 3, 5 adding to 8 is bad. And then 4, 5 adding to 9 is bad. So it has to be 2, 3. That makes that a 5 and a 3. That makes that a 5 and a 3. And this is a 4 from the 2, 3. So this is 1 and 2. There's a 2 up here somewhere. So the 2 is going to be... This is either a 1, 2 or this is a 1, 2. I don't know which. I don't see which one of these is a 1, 2. Oh, this can't be 1, 2 because it's connected to a 24 cage. So this is the 1, 2. That's 3. There's a 1 right here. So we've got 4, 5, 6, 7, 8. Not a 6. That's not a 6. We placed the 6. There's a lot of lows here. 2, 3, 4, 5. Quad. Basically, the other 7, 8, 9 goes here. This adds to 12, so... Oh, that can't be 7. So with an 8 or a 9 adding to 12. So 8 plus 4 or 9 plus 3. Can't be 4, so this is 3, 8. 9 goes down here with a... Wait, why did I do 3? Hold on. Hold on. 9, 3. I'm glad this is the last puzzle because something's going on in my head right now. Let's see. I'm just tired, I think. Two and 3, 4 and 2, 5 and 3, 4 and 5. So we need the other 7 or 8 in here along with a 4 and 5. But it can't be a 4. So it's 5, 7 adding to 12. And this is the 4, 8, making that a 7 and an 8. There's a 5 down here. The 9 looks down, thank you, that's a 2. 8 looks up, 4 and 8. 2 looks up, 1 and 2. This is 7 and 9. This is 1. Okay, I'm sure I can just finish this with Sudoku. So I need a 1 in this box that goes here. I need a 2. I have a 2. I need a 3 in this box. I think any... Oh no, 3 is placed. I need a 4. It's one of these two. Ah, it's actually that one. I need a 5 in the box. Oh, yeah, that 3 finished that, so it gives me the 5. I need a 6. Oh, this is finished, though. Anyway, I'm going to place my 6. It goes here. I need a 7. That goes here. I need an 8. And then over here, we've got 7 and 8. And there we go. Thanks, Philipp. That was a neat puzzle. I've actually seen that idea before, but I don't know if I've seen it with negative constraint. But it was cool regardless. And it took the perfect amount of time to wrap up the stream. Betzel was a 7. Yeah. So I have another stream tonight. I'm going to see Doctor Strange in between. So hopefully that'll be good. I hope it's good. Going to do my thank yous. Thank you very much to Pause, who just re-upped their 3 months membership as a super supporter. So thank you very much, Pause. Also to the Asylum and Peter and Distensity and David Ratner for being super supporters. Peter used his super supporter perk today to get his puzzle to skip the queue. So if you're, interested in that, that's a perk you can get for being a super supporter. Also, thank you to all of my members and all of my patrons who are scrolling down below. If you want to join, you can click the link in my description. I have a link both to the member joining and my Patreon. And I also have a link to my merch shop where you can buy stuff with the Rocky logo on it. Super cute. Other than that, thank you to everybody who stopped by, and I'll see all of you tonight.